If you misunderstand how AI learns different from human, you will misuse it. And that's exactly what happened in most companies today. In this video, I will explain the fundamental difference between how human and even animal learn about the world compared to how AI systems learn. Draw from insights by Yann LeCun, I will show you why this isn't about intelligence levels, it's about learning mechanisms. And once you understand it, you will start to use AI more strategically, more realistically, and more effectively in your work. My name is Celine Xu. Welcome and welcome back to my channel. I help business professionals and organizations make smarter decisions about AI and AI adoption, so technology creates real value instead of risk. Let's dive in. First, let's find out how human and animal learn. Human, dogs, cats, and even babies learn primarily by observing the world, acting in it, experiencing the consequence, and know what to happen. Key characteristic of biological learning is grounded in physical reality. Learning happens from continuous, noisy, high-dimensional signal, like vision, sound, touch, motion. And learning is predictive, not descriptive. So when you think, if I do X, what will happen next? And then you will do it and you will verify it. Examples. A baby learns that objective 4 when released it. A cat learns that jumping from certain heights hurts. A dog learns that pushing an object moves it. Critically, human and animals learn before language, not through it. Language comes after a deep internal model of the world already exists. Then, how today's AI learn? Modern AI systems, especially large language models, learn by consuming vast amounts of text, predicting the next possible token, memorizing correlation between symbols. Key characteristics of AI learning today are, first, learning is symbolic and indirect. Second, training data is most text, detached from real-world interaction. Third, knowledge is stored as statistic association, not causal models or factors. Four, understanding is inferred from patterns, not experience. In summary, large language models don't understand the world. They approximate how humans talk about the world. A large language model can explain gravity perfectly, but it has never experienced an object falling. It knows gravity only because humans wrote about it. What this means, AI can answer questions correctly while having no real understanding of the underlying phenomenon. You may now ask, why AI cannot currently learn like humans? LeCun highlights 4 fundamental blocks. Let me break down for you. First, AI lacks grounding in reality. Text is an compressed, incomplete description of a children see and thousands of 4 hours of a real-world interaction by age 4. The entire internet text is equivalent to a tiny fraction of the scenario data. Text removes causality, physical uncertainty, and embodiment. The consequence? AI knows facts, but not why things happen. Second, AI does not learn by predicting the consequence of actions. Animals learn by comparing reality with expectations. They will think and test. What will happen if I do this? And learn. Babies show surprise when physical rules are violated. This means they have internal expectation about how the world runs, the physical laws. But AI show no surprise, only pattern matching. Most AI today predict words, not able to simulate outcomes of actions if you do not ask. Not plan in a causal sense when solving a problem. That is why when you let AI create a video about a cat push a table with a cup of water on it, in a series of animations, the cup may not fall, the water may not spread, but a cat hits a table and there will be a whole cup standing on the ground. Models will also not automatically know, solid objects block motions, or a person cannot be in two places at once. AI systems do not discover those rules. They imitate the explanation of them. The consequence, AI is weak at planning and reasoning in the real world and handling novel situations based on those unspoken common sense. Third, AI memorizes correlations instead of forming abstractions. Humans build abstract models. We have goals and process frameworks. When we're facing a specific problem, we ignore irrelevant detail and keep what matters for prediction and decision making. You could argue also influenced by cognitive bias, but we still compress reality into usable abstractions. However, many AI systems today memorize only surface-level pattern, massive number of correlations. They request enormous skill to appear competent and often struggle to generalize beyond their training data. Why? Because all internet text is only equivalent to very limited real-world exposure, but a child experiences richer information in just a few years of life. A children can extract the correct pattern from only 2 or 3 examples, but AI often need hundreds or thousands to calculate the possibilities. More, text data is sparse, low in redundancy, and poor at convincing causality. Here is the catch. Intelligence requires abstraction, what we call logic, not just producing details. Fourth, AI training ignores uncertainty and unpredictability. The real world is continuous, not discrete tokens, noisy, a lot of irrelevant information, partially observable and uncertain. But large language models work best when problems resemble their training data. Inputs and outputs are clean and symbolic, like games, chess, full observability, discrete action, perfect rules, and you will easy to judge right and wrong. AI dominant there. But in reality, lots of hidden information, uncertain, continuous dynamic, and there is no right and wrong answer. AI still struggling there, which means AI excel in narrow artificial setting and fail where real intelligence matters the most. Then, what are the consequences of those gaps? First, AI appears smarter than it actually is. Because language is persuasive, AI sounds confident, feels intelligent, and can mask a lack of real understanding. This leads to overtrust, misuse in high-stake decision, and AI hallucination being mistaken for reasoning. AI doesn't understand, it predicts. But fluent prediction can look like intelligence. 2. AI is brittle and unreliable in a real world. Without an internal world model, AI struggle in robotics, autonomy operations, and complex logistics. It cannot reliably plan or act independently over long-term tasks. It still requests heavy human supervision. It performs well in controlled environments, but it breaks in messy, unpredictable reality. 3. Scaling alone won't fix the problem. More data, more computing power, or more parameters do not equal to more human-level intelligence. Without new architecture that learn word models, predict consequence, operating in abstract representations, progress will plateau. Bigger models are not the same as better learning. All those delay the true useful of AI. The AI that really matters is not a better chat, better marketing copy, better summarization. It is AI can simulate outcomes and solve real problems along the way. AI support real decision making or understand physical and social reality. And AI can self-improving based on each iteration. Without a human-like learning mechanism, the level of AI remains out of reach. Here is the core message. Human and animals learn by living in the world. AI mostly learns by reading about the world. Those are fundamentally different. Bridging the gap requires new approach, not just a bigger model. Or put this way, until AI learns the way a child or a dog learns, through interaction, prediction, and abstraction, it will remain powerful, impressive, and fundamentally limited. If you want real AI strategy without hype, subscribe. Drop a comment below. What's one task where AI gives you confident answer, but you still double check it? I read every comment, and I will give you practical advice on how to improve it. Love to have you to hit the like button and share it with someone needed. Thank you for watching, and see you in the next one.